So this will be the solution to integral exercise level 2 on partial fractions, and this is question 1, part 2. So we want to express this as the sum of partial fractions. So the first thing to do would be to actually factorise the denominator, because we can't do partial fractions unless we have linear factors in the denominator at the moment. So that, I've miscopied it, that was meant to be a minus, which makes it much easier. Difference of two squares, I have x plus 2 and x minus 2 on the bottom. And we know that we can always split this up into partial fractions with a over x plus 2 and b over x minus 2. Now if I was going to add these up, I would want to make a common denominator, so I would have a x minus 2 plus b x plus 2 over, and that is still exactly the same as this. So I know that if this is an identity, well then the numerators, because the denominators are the same, so the numerators will definitely be identical as well. So x plus 1 is identical to a x minus 2 plus b x plus 2. Now I want to substitute in some values into here to eliminate one of the a and b. So let's start with substituting in x equals 2. If I do that, I have 2 plus 1 on this side, which is 3. Over here I have 2 minus 2, which is 0, so that's 0 times a, 0. And over here I have 4b. So if 3 equals 4b, well, b must equal 3 quarters. So that's 1, and my next thing I need to substitute in is negative 2, because that will make that one equal 0. So now I have negative 2 plus 1, which is going to give me negative 1. Then if I substitute negative 2 in here, I'm going to have negative 4a. And in here, I'm going to have 0. So a is equal to 1 quarter. So I have my values of a and b, but it actually said express as the sum. So to do that, I want to write my original fraction, x plus 1 over x squared minus 4 is identical to, okay, I'll put my a in. So since I had a fraction, I just want to put 1 on the top, and then I want to put 4 outside the bracket, x plus 2. And then for b, I've got my 3 on the top, and then my 4 outside the bracket, x minus 2. And that is expressing it as the sum of partial fractions. That's the final answer.